G'day and welcome to the second part of the video on complementary angles. So finding out the answers to questions that are taken from the vertical axis, the y-axis, rather than the horizontal axis. You probably need to watch the video just prior to this, just to make sure that you understand what I'm attempting to do. But in the previous video, I showed you that sometimes a sine value can turn into a cos value, and vice versa, using complementary angles. So I think we had these rules down here. Sine of pi and 2 plus theta ends up becoming cos theta, and cos of pi and 2 plus theta ends up becoming negative sine theta. And that was all to do with the x values swapping to become y values, and so on and so forth. I won't go into it again because you can watch the other video. But if you ever, I guess the summary I just want to remind you of again, if you ever go from the horizontal axis, which is usually what we do. So if you're trying to find sine of 240, I would usually say that that's 180 plus 60, rather than saying that that is 270 minus 30. So 180 plus 60, then I use my special triangles to find out the answer to that question. But so if we're ever going from 180 and 360, sine stays as sine, cos stays as cos, tan stays as tan. But if we actually use the angle from the vertical, for example, if I had one sine of 120, I could make that actually sine of 90 plus 30. And in which case, if I did, then the sine would actually change to a cos. So I'd actually find out what cos of 30 is and go from there. This is a quick summary of what we just did. Now, tan is a little bit different from this, as I mentioned in the previous video. We know that tan is the same as sine over cos, but check this out. So tan of pi and theta, pi and 2 plus theta, is actually equal to sine of pi and 2 plus theta over cos of pi and 2 plus theta. Now I know that sine of pi and 2 plus theta is actually equal to cos theta, as I was shown in the previous video. And cos of pi and 2 plus theta is actually equal to negative sine theta, as shown in the previous video. So I've actually got cos theta over sine theta, rather than the other way around of sine theta over cos theta. And I can tell you that that actually equals negative 1 over tan theta. I mean, you can prove this by simply flipping this side to make that tan over negative 1, and flipping this side to make that sine over cos. So cos over sine is actually 1 over tan, and the negative is obviously there as well. So we know that tan theta is actually equal to sine theta over cos theta. So if we have 1 over tan theta, sometimes the calculator can spit out that the answer as cot theta. People who have done specialists will have seen this idea before, cot theta. We don't actually need to understand this too much in methods. We just need to recognize that if I've got tan of pi and 2 plus theta, that's actually equal to cot theta. Or sometimes later on when we do calculus, you need to understand what cot theta is. It's simply cos over sine rather than sine over cos. Cot theta is 1 over tan as well. Okay, so that concludes the videos on finding out angles using the complementary angles, or finding out the answers using complementary angles. I hope that's helped a little bit. I'll say most of the time we find our answers from the horizontal, from here, because it makes things a little bit easier. But it's disappeared. But occasionally we can actually find them from the vertical as well, and that was when sine changes to a cos, cos changes to a sine. So in the next video, I'll have a look at the special angles so that we don't need to use our calculator as much to find out the answers. So thanks for watching.